This last subsection is called Solving Applied Problems Using the Law of Sines. In your textbook, there's one example and one try-it question, so we're not going to linger here. It's a very specific situation, but it can be applied to any time you have two known angles and a known side length, included side length. So for a slightly different example than the ones in your textbook, I'm going to use two sailboats who are, let's say, 500 meters apart. And they're just sitting there, maybe they're friends or whatever, and they're on their radios, and one of them says, I think I can see a sunken ship below the water here. And the other one goes, oh my goodness, I think you're right. I think I see it too. So they get out their, I don't know, compasses, sextants, something, and they're able to determine for the ship on the right here, the sailboat on the right here, that the angle of declination, or the angle of depression, it's sometimes called, the angle down from the horizontal line at which they're viewing that sunken ship, that angle is 35 degrees. For the other folks, it's 20 degrees. You're looking down from the surface of the water, 20 degrees, and down from the surface of the water, 35 degrees. So they know, because they're avid divers as well as sailboaters, that you have to have your scuba gear can only sort of work down to a certain depth. So they need to figure out if it's going to be worth diving for this sunken ship. They need to know what the depth below the water is. How can we find this? Well, this is basically the setup of the questions in your textbook, both the example, which is example 6, and the try-it question, or try-it number 6. In those questions, you're asked to find an altitude, which is a certain distance above the horizontal, above ground level. Here we're looking for a distance below the horizontal, below ground level or below sea level. And other than that, the problems really are identical. We have two known angles and an included known side. We're looking for the height, the depth, the distance, the altitude, whatever you want to call this, and however you want to label it. I'm labeling it height just because H for height, just because height is it's a pretty common label here. I'm not actually going to do this entire problem because I think the example does a pretty good job of showing you how to do it. But the basic setup is that you can't use the law of sines here unless you know a side length across from an angle. You need at least one pair of an angle and the side across from it. So we don't have that one. For this angle here, we don't know this side. And for this known side length, we don't have the angle. We don't know what this angle is. So how are we going to find this height? Well, we can use the fact that the angles in a triangle, I'm going to call my unknown angle x for now, they all have to add up to 180 degrees. So when I do this arithmetic, I'll have I'll have the size of angle x. Now I have a known angle across from a known side, and I can use those two pieces of information to set up the law of sines. I think I'll go with the 35-degree angle. Why not? So now we need labels for these sides, right? Let's call this A. I don't know, doesn't really matter. Let's just give it a label. And because I know x, having done this work, I know x, I can find A here. I can find the length of this side. Once I've done that, I'll be able to write the sine of 20 equals h, which I do not know, over A, which I do know. The sine of 20 degrees equals h over A. Multiply both sides by A, and I get A sine of 20 equals h. Remember, I've done some work here, so I know what A is. I know the value for A. I know the value for A. I can calculate the value for the sine of 20 degrees. And my H is very messy there. Okay, so I can calculate this value here, and this is actually what I'm looking for. I'm looking for H. I'm looking for the length of this line segment, and that's going to tell me the depth. And that's pretty much all there is to it. And I've given you a completely different scenario here, but all it is an angle side angle, and you can find the height of the triangle using that information. It takes a few steps, but that's all the information you need to do those. That's the end of section 8.1. In 8.2, we're going to be talking about something called the law of cosines.